Namaste. Today, I want to talk a little more about programming because we find that a lot of people who are um, graduates of computer science or information technology with experience, but have challenges in building working good quality programs. Okay, so one of the reason is that we focus when we learning programming, we focus more on the language, the nuances of the language, rather than how to use the language in constructing efficient, good quality program. So how do we build this? And this is something that you is very hard to teach explicitly, kind of like how to write good essays in English or how to uh, write a good report. These are things which are much harder to teach directly, right? You need to do it with practice. So here is some advice or some suggestion that I have. So let's say when you are writing a program, you are writing a program to do anything. Let's say from a five-line Fibonacci number program to let's say 100-line program or a 1,000-line program. So once you write this program, try and ask these following questions, right? So the first question to ask is, what are the inputs for which your program is supposed to work, right? So when you are asked to write a program, that would tell you that your program should work for, the input would be something like this. Let's say if it is a sorting program, it will be say that you sort n number of integers, and the maximum value of n could be, let's say, 100 or 1 million or whatever. So you would get something like, what is the type of item that you want to get, you would be getting, and how many items are there. Now, the item that you get may not be a simple number. It could be a record which has a name, date of birth, and salary, or whatever, something like that, right? So, what is that space of input, and what is the minimum and maximum size of that input that is expected? This you should check and ask the question: where does my program will my program work efficiently? Work for my for that any input which is subscribing to that specification. Why this is important is, for example, let's say you are writing a program Fibonacci numbers, and when most people, what you do is that if you write a program for Fibonacci number, you would write it for n equal to 5 or n equal to 10. Now these are very small numbers, right? So it would be like about the order of 100 or so. And so if it works for n equal to 5 or 10, and you are very happy with that, and everything is fine. Then somebody goes and sets n equal to 100 and runs that program, and everything crashes. Because for n equal to 100, your algorithm's efficiency is going to be very important, because if you follow, let's say, an exponential or recursive mode of computing Fibonacci, like fib of n equal to fib of n minus 1 plus fib of n minus 2, you will find that fib of 100 can take 2 to 3 hours of running time. And more than that, the nth Fibonacci number is a huge number. Your long or int actually doesn't accommodate that precision. So you need a completely different way of looking at the problem to address that level of complexity. So the first question to ask is that, beyond the number that I have used to test my program, or what is put in the program, will my program handle the full range of inputs which it's supposed to handle, right? So this is your first check to do. And assuming that it does, and you will need to test it out with some random variation. So which is why we tell that you should choose different boundary cases, and covering the minimum, the maximum, and all that. Numbers could be negative, zeros, duplicates, non-duplicates, all of that. So if it works for those, the next question to ask is, suppose your user actually doesn't conform to that input, and he actually gives you something that is outside. So if your input is to say that you sort a number of n numbers, and I actually give a string or I give something different, what will your program do? Will it crash because you do a readint and then you get a string and your program crashes, right? Or will it actually recognize that, the input is not quite what I want and come back and give you a message saying that, I think, look, there is a problem with the input. I'm not able to handle this. So, please check it or rerun it. So this is what we call a graceful failure. So when something goes beyond the expected range of things, will your program at least capture that I'm going out of it? If it's able to recognize what he is trying to do and give a good feedback, even better. But that may not always be possible. So will it recognize that you are going out of the space and tell him that, look, I don't know how to handle it. This program is not supposed to do that. So this is your second check, and which is where most programs actually fail because we don't actually tolerate any deviation from what is allowed in the input. The third question to ask is to look at how much time does your program take. Now again, what happens is when you write your program at a school student level, you would actually assume very small inputs. So if we ask to do a sorting, you will possibly take n equal to 10 or n equal to 100, and you will find that sorting algorithms run quite fast. Now, so therefore you are relieved. But then as n goes larger, if we are supposed to handle up to, let's say, 1 million number, so 1 million records or 100 billion records, will your program scale? How much time will then your program take? So you can simulate it by giving a large input. You can do all that. But look at your program and ask how does your program scale with the time as you pick up as your input actually grows in time. Okay, so you should time for the small value also because sometimes even that gives you an idea. Give some inputs of different sizes and measure the time. And it will actually be very revealing to you, and that is actually where the complexity of algorithms and algorithmic complexity and all that comes in there. So this is a very good exercise to do that and ask the question, for the range that you are supposed to handle, how much time will it take if the most complex of that input is actually given to your program? The fourth question to ask is, how much space does your program take? I mean, the RAM space, how much of dynamic structures do you create? How much of connected structures? How much data do you store? So, I mean, some of you might remember this program, usual interview question says, if I have an unknown number of large numbers, how do I compute the average of those numbers? Now, if you take sum of these numbers and compute the sum of these numbers and divide, that will actually overflow. So there is a way to do algorithm average without actually having to compute the full set of numbers or to keep the sum of the whole set of numbers. So it is useful to understand what is the space requirement of your algorithm and in terms of the RAM space as well as any disk space that you occupy. You might be writing a lot of files and more database backup or whatever that you will do. So look at this requirement and ask the same question. As the input size grows to the maximum that it's supposed to handle, will your space become unreasonably large? Right? Because again, for small data sizes, it's quite okay. I mean, you may not feel that pinch when you are masking a lot of space and a lot of redundant data storage is there. But when the data size, the input size grows, they actually become a liability that even on very powerful machines, your program goes slow. The fifth question to ask is that suppose your client comes and says, no, I want my program to become broader in scope. I had told you that you should do for integers, I want to do the sorting, but now actually I want a record sorting, my multi-field record sorting, or I want floating point numbers, I want complex numbers, I want to whatever else, right? So if they come back with a change of scope and say, want your program to become with larger scope, but let's say within the broad category, it's still a sorting program, but just that the input is different or the sorting criteria is different. How much time or how much effort will you require to adapt this existing program to that requirement? Usually the tendency to throw it away and then say, okay, I'll write a new program. And this is not always practically feasible. So can you look at structuring your program with the right kind of parameterization, the right kind of abstraction, the right kind of modular structure that these kind of modifications are relatively easier. Of course, a lot of modifications will take a time because you might have to change the algorithm, you might have to change the code, the structure that you are using to store it and all that. But even within all that, how tolerant is it for actually handling a bigger size? And the last, possibly most interesting question to ask is, how beautiful is your code? And of course, programs also have elegance and beauty associated with it. It's just like when you read a good article or a good book, you say, "Oh, this is so nicely written, so beautifully written. The depictions are so nice and so on." So you feel happy when you read a good book, and when you read a badly written book, you feel very very uncomfortable. This the same story goes for programs also. How beautiful is your program? So this has two layers. One is the purely appearance layer. Are you using good variable names, not IJK, LMNOP, or even words I1, I2, I3, I4, but they actually have meaningful names, properly structured with underscore or the Java type of capitalization and small modules or functions, not something that goes into 10 screens for one routine that I just have to keep scrolling up. That's not bad structure of code, because it's become very difficult to understand what is the implication of something that is done above to the lines that is below. How much of global variables do you use? Okay, and it is something that you should minimize. How much of interdependencies are there? That's something that you do somewhere else. Or is there a dependency here? Through in various ways. It could be pointers, it could be global variables, it could be modifications outside, and how clean is your abstraction. So if you take examples like a tree traversal code, which is with its almost a variable free procedure of just 4 lines, which you can adapt to in order, pre-order, post-order very beautifully. So there are beautiful algorithms, beautiful code, beautiful so programs, which is also something that is worth a trying. It's not just the aesthetic part of the beauty. It is also because beautifully written, clean code is much easier for anybody to understand, to maintain, to support it. So I'll keep asking these questions for every program that you write. It doesn't matter whether it's a small program or a big program, and try and see how you could have done this program differently, so that you have a much more positive response to these 6 questions that I have listed here. Make that as a practice. I think you will find that your programming capability significantly gets better, and the program that you produce is also much cleaner, much neater for people to look at, and even for you to come back a few months later and understand what is going on. So thank you. Take care. Till we meet again.